Hello. Right, today I'm adding one of these MKS Servo 42D kits to a little stepper I've already got. I've got a couple of these to do for one of my projects. Now these things, they're a nice little kit. I haven't actually used one yet, but they look very nice. They're well made. They convert a normal step motor to a complete self-contained closed loop stepper and driver assembly. So at its simplest, you can use two power wires and an RS485 data link, just two wires on a serial port with direction control at the other end, to completely control the motor for positioning, and even connecting the limit switch on the axis. If you're using a limit switch, a home switch or limit switches, you can even connect them back through here with the proper settings and read everything remotely on the same two wires. So it can massively simplify setup and wiring and control for stepper motors and a project. Anyway, the first thing is to put the magnet on the back of the shaft, which I've done a separate segment for, so I'll switch to that now. Okay, so with the magnet mounted, the next thing is to put the little tiny piece of heat transfer tape, which is a kind of foam material heat transfer tape, over the power driver ICs on here. Now this is from a NEMA 17 motor. There's a bigger version for a NEMA 23, that's the Servo 57D, which has rather than four half-bridge drivers, it's got 8 individual power FETs because it's a lot more current capable. But these are pretty good in themselves, so up to about 3 amps or so. And the assembly after that is basically thread the bolts through the, well no, I'll put that in first, it's easier that way. That fits in, take that off. That fits into the back of the heatsink. Now the heat transfer tape's on, and there's a little block in the back of that. I don't know if you noticed that the tape presses against it, so it is designed to act as a heatsink. Then from there, I'll put one screw in. In fact, no, I'll put all 4 in. I don't think the motor's going to fall apart. The thing is, if you do all 4 together, you've got to take all 4 screws out of the motor. But I have a feeling the motor won't pull apart easily, so I'll do it all and go risk it. Then you put the little spacers on, so the casting is held in place, and the PCB is held in place within the heatsink casting, so you don't crush the casting, leave the PCB floating about. And basically just take the screws out the back of the motor. I don't find my screwdriver. Take the screws out the back of the motor. I'll be careful that it doesn't fall apart in the process. I don't think it will. Not quite out there. So take 4 screws out. You can buy these things completely with a motor and assembled, but they cost a bit more than just the bare board. I've already got the motors, so I'd rather use the kits. I like building things anyway. And the modules are addressable. You can set in the parameters. You can give it an address on its serial bus. And there's also a CAN bus version if you prefer using CAN. You've got a controller board that's got CAN capability. It can be programmed to suit. So you're giving it an address in the parameters on there, and then you can have several boards. Oops, several boards working on the same 2-wire bus, just with a terminating resistor at the other end. It's a twisted pair bus. Right, now one thing I do want to do, because these are obviously going to experience some vibration and torque and things, is I want to put a bit of Loctite on, which that stuff lives on my desk. Just make sure it doesn't spit. For small things, again, I'll transfer it to a bit of plastic rather than trying to drip it straight on, and then just dip the screws in it. See, it's actually, capillary action is actually pulling it around the thread, so the threads are completely wrapped in the Loctite or thread lock, whichever you're using. It's some other make. Right, and just make sure the 4-pin connector, and make sure you don't lose those, make sure the 4-pin connector is in line with the motor connector, and put the screws through. So it should look like that. 4-pin connector in line with the motor connector, and the 2 control and switch connectors either side. And so I'm going to keep holding it together with a bit of pressure on it, and just nip those up. Just get them all in just lightly tightened first to start putting a bit of pressure on, and then go around and tighten up in stages so I don't twist anything or risk, unbalancing the ends. If there's something like this with ends sticking out, if you tighten one to a corner too much, there's always a chance of something rocking and actually going out of line, so it can't tighten properly. So I'd always do them progressively and work opposite diagonals. And this is probably okay because the screws are all within the body of the motor. But some types of thing with clamps, once they go off square, if you continue tightening, it won't go back to square. Right, now I'll put some proper force on the thing. Now it's nipped. That should be it. That's the last one there. Right, and the last bit on that then is to connect the little motor jumper cable back to that. Now, there's one silly thing with this. This is pre-tinned ends. You should never ever put tinned wires into screw terminals. For power wiring, it's been actually against electrical safety regs for a very long time. And the reason is simple, that solder flows. That can compress over time with expansion and contractions, just with temperature changes, things change size. And the solder can be compressed more whilst it's in the terminal, and the connection can loose over time. So I don't go in tinned. Sharper cutters as well for those. Those are getting a bit tired. Excuse me. Particularly good ones. I want to trim about 5mm on each one, or strip. I'll take the end off, and try and take all the force on the wire as well, not on the connector, so I don't pull the connector off. There we go. I'll try and nip the insulation without damaging the wire. The insulation as weak as possible to make it easier to strip. Wow. It is on a short bit of wire like that, there's still not much to hold on to. Could be better off with wire strippers, but I've not got any suitable short reach ones to hand. The only ones I've got in there need a lot of wire to work with to grip it. This is a bit small. So, because these are very small terminals, that folded in half will be adequate. Now I need a screwdriver to fit that, which is that one. It's only about 2.5mm. Not sure what, 2.5 probably. Oh, it's nearer 2mm. 2mm blade. These terminals, that's another tricky thing. These are rising clamp terminals, so there's not much space there, but it's below the clamp. you've got to undo the things to open the clamp. You see the clamp section, hopefully. You see that moving down. That's got to be fully open before you put the wire in. Just trying to get all the clamps. The clamps were sticking to the screwdriver slightly. I think they're all open at that now. Now the next thing is then, just double check the motor wiring, because there's two different wiring patterns on these that use exactly the same connector. Some have two windings on the side-to-side pairs. Some have them on alternates. So it could be red and black for a winding, or it could be red and blue for a winding. So I need to check that with the multimeter. I think it's going to be probably the straight red and black one, but I don't know for sure. Just bring that into view. No, it's not. No. Good thing I checked. Yeah. So it's red and blue. This one's alternate. And black and green. So those two need to swap over into the terminals, or else it's not going to work. Because the driver is specifically one winding on the left, one winding on the right. So I'm going to put the middle two in first, because they're going to be the more awkward ones. Fold the ends back on themselves. So it's only a very little bit in the terminal, the tiny terminals. And folding it up gives a bit more metal for the terminal to grip. I've just nipped in. I can go around and tighten them all again later once they're all in place. I was trying to arrange that crossover a bit. And the outer ones. That should be complete. Now I can't test it yet because I've not got anything with any software written yet to actually control the thing. But you can also use these as in step and direction mode. They are very versatile. The only thing that's different between the two versions is either the bus wires are either for CAN or RS485. The rest of the terminals are pretty much the same, I believe. What I can look on the see on the data sheets. Look at the data sheets, and you can use them in step and direction mode, as with a lot of simpler servo drives. Just these got the extra serial link capability. Get these all fully tight. And that's ready for use. And so these modules are, the little kit modules, add-ons, are all the complete motors. I don't know exactly, it's probably not exactly the same motor as this, but similar style. Are available quite a reasonable price on AliExpress. About £12 for the board, or I think about 18 for a board and completely built board and motor assembly. They do need configuring. And I've not yet looked at the menu on this at all, so I might just put power on it without anything else and see how I go about configuring it and setting the address and things. So I'll just pause for that for a minute until I get a power supply sorted out. Right, so I've hooked it up to one of my battery packs, or got it ready to hook up. I'm going to turn the light out so you can see the display better, hopefully, and see what happens. Not cal. Okay. I've got the manual for it on screen. So I have to. Which button's which? Okay. The buttons are labelled in the manual. That's next, enter and menu. So go to next mode. Okay, you just cycle through. Cal, next, what was it, enter, enter, right, okay. Oh, that's actually turning the motor shaft. Cal done. Okay, I assume that's calibrating the encoder then, as the magnetic encoder ICs on the back of the circuit board, so it's close to the magnet. What time did you try and turn it? Oh yeah, there it's now reading angle. Do it without pulling the wires out. It's now reading the motor angle from the encoder. That's neat. Back to menu. Mode. Enter. Serial. You've got three modes: open and close. You've got I think CR is step and direction, I think, and SR is serial interface, and then the operating mode within that. So you've got open loop, closed loop, and field oriented control. So I'll go to closed loop, I think. Yeah. MA. Set the motor current, which I've not a clue, I'll leave that as it is. It's set at 1.6 amps. Holding current when it's not trying to move, it's just holding position. 50%, okay. Multi-step, I think that's how the division, multiplier or whatever. So that's 16 microsteps per full step, which is plenty for what I want. Enable, low or high. Again, I'm not going to mess with that just a minute. Direction. Normal, depends which direction you want to consider, clockwise or anti-clockwise, so you can reverse it depending on the mechanics you're connecting to. Auto 500, I have not a clue what that is. I'm going to have to look in the manual. Menus, right. Yeah, CR is pulse interface, SR is serial interface. Auto SSD is automatically turn off the screen when it's in idle. I'll leave it disabled for now. Protection. That's lock rotor protection. I'm not going to mess with that in a minute. Multiplier. Oh, internal 256. That's already set. UART baud rate. That's definitely wanted. That should be 38.4. Yeah. Address. So 1, first motor in the system. RSP, what's RSP? slave response. Enable and disable response. Right. Look what the default is on that. Enable, I'll leave it on that because that's default. Modbus, I don't want. I'm not using Modbus. I'm using just direct RS485. So that's disabled. That's okay. Zero mode, I want disable. That will automatically run it as soon as you put power on to find the home switch. Which, because this is going to eventually go on a multi-axis machine, I won't do that because it's got to home in a certain speed sequence. Disable, that's okay. Set 0, what's set 0? Oh, that's the where you want it to home to after it's referenced. Again, because I'm not doing that. Zeroing speed, travel speed to set it slowest, I think, for now, until I find out how it works. Direction, I don't know. HM. Oh, that's end stop switches, level low or high, which again I don't know yet. That's all homing setup speeds and things, which I don't want to set yet. All right, end limit. This is I have looked through the manual, so I'm trying to remember bits. Right. No. Yeah, I think that's it. That's basically all I need to set for now, and not knowing everything about it. So. Okay, it looks like it automatically saves all the parameters. There's a restore to restore the factory defaults, but there's no save in the list. So hopefully that's set. But yeah, it's quite a neat little unit, the built-in servo. Next thing I'll do is actually get the software working to see what I can make it do. But that's not going to be on this particular video. Anyway, that's it for now. Thanks for watching.